Our lesson for today will be looking at chemistry 1502. The topic for today will be looking at the formation of alkyl halides. Lesson 101, let us start. In the previous lessons, we've talked a lot about alkyl halides. We also looked at the reactions, but we've never covered the topics whereby we look at the generation of alkyl halides, the formation of alkyl halides. We know what are alkyl halides. We also know the types of alkyl halides, especially when we're dealing with SN1 and SN2 nucleophilic substitution reaction. So in this lesson, we'll be looking at how do we form alkyl halides. You should know that alkyl halides, they are produced by a reaction between alcohols and hydrogen halides. The word halide is from those elements in group number 7 or group number 17, which are halogens. And then when we say hydrogen halide, we're talking about a hydrogen bonding with one of those elements in group number 7, which are halogens. Then we refer this to hydrogen halide. For alkyl halide, remember that we have alkanes, alkenes, and alkynes. You should also know that we have the alkyl group. For the alkanes, we know that we have methanes, we have ethanes, propane, butane, and then for alkanes we have ethene, propene, butene, and then for alkynes we have propyne, ethine, butane, and then for alkyl we have the methyls, the ethyl, the propyl. So just to explain this so that you understand chemistry better, remember that this belongs to the alkanes, which is methane, and then should it happen that we remove this, you can see that this serves as a substituent, and then we call this substituent as methyl. And then once we add a halogen here, it becomes an alkyl halide, meaning that when you talk about an alkyl, we are talking about this type of a substituent. It belongs to the alkyls. We have the ethyl, which also belongs to the alkyl, and then this is a halide. That is why the word we have alkyl halides. This is so back to the formation of alkyl halides. You should know that an alcohol reacting with hydrogen halide, we are going to produce an alkyl halide and water. Some would say the hydrogen halides as acids, which is very much true. We will be looking at different types of hydrogen halides, but master this general reaction. Whenever we react in alcohol, we are going to form, whenever we react an alcohol and hydrogen halide, we are going to form alkyl halide and water. And yes, this is a substitution reaction because you can see where there was hydroxy group, we are going to substitute it with a halide. Then once we talk about substitution, you should know that we are going to be reviewing SN1 and SN2 reaction. Looking at hydrogen halide reactivity, you should know that the strongest hydrogen halide is hydrogen iodide, and then we have hydrogen bromide, we have hydrochloric acid, Then lastly we have hydrofluoric acid. And you should know that these, the last two, they would require a catalyst in order for them to react. And then the first two, they don't really need a catalyst. So let us look at our first reaction. Suppose you have by the way it's butanol. We react it with HBr. We can just do this, also do the very same thing here. We know that definitely sure that we are going to get Br and water. Let us look at the mechanism. The first thing that will happen, we know that OH is not a good living group, so we have to protonate in order to make it a good living group. What will happen is that we're going to protonate by taking this hydrogen from Br going to be a bit slow so that you understand this. And then we are going to have our oxygen here with the hydrogen which we protonated from HBr, and then we have this hydrogen which was there. Then we know very well that oxygen is a divalence atom, meaning that if it bonds 3 times with lone pair, it's going to have a positive charge. You should know that if it bonds 3 times, the bonding is 1, 2, and 3. If it bonds 3 times, you should know that it will have a positive charge and it will have this lone pairs. If it bonds once, it will have 6 lone pairs with a negative charge. If it bonds 2 times, it will have a neutral charge, meaning that you don't have any plus minus, and then it will have 4 lone pairs. After protonating, it simply means that our Br will be alone with eight electrons. Remember that when we protonate, we simply take this, and then it simply means that this bond will go to Br, and it's very important to show this movement as part of the mechanism so that we know where these electrons they went from to. Now looking at this new substrate, we can clearly see that this is a good living group, which is water. So what happens is that the substrate will leave, the living group will leave the substrate, but you should understand something. Let's talk about primary and secondary carbocations. We know that this C here is a carbocation because of this positive charge, and then we have this one will be less stable compared to this one. One thing you should know is that secondary carbocations are more stable compared to the primary. They get the stability from these 2 carbons. Looking at this one, it doesn't have carbons which they can make it stable. That is why most of the time, should it happen, let's say from the primary we have this methyl here just next to the carbocation, it will try to stabilize itself by shifting, meaning that you are going to have a methyl shift whereby we can have something like this. Let me quickly redraw the first one. So this will try to stabilize itself to be this. Now if it is like this, it is stable. Should it happen that we have a methyl here, it will try to stabilize itself again. So we can see the reaction most of the time will try to avoid reaching this state whereby it is not stable, it is a primary carbocation. So instead of trying to undergo a rate limiting step whereby it produces a carbocation, it will actually have a nucleophile attacking before it can form a carbocation, meaning that it will try to avoid reaching that point whereby it will have a primary carbocation, whereby it does not stabilize, it cannot shift to an extent that it becomes more stable. So in this case you can see we don't have the methyls, we are just dealing with a primary carbocation. So in this case a nucleophile will back substitute or back attack before it reaches that point, meaning that we are going to have, we are not going to be looking at the stereochemistry in this case, and then this good leaving group would be here. Now you can see the product, we have our alkyl halide and then we have water. So in this case you can see that this is SN2 reaction. That is why when you look at the stability of SN2 reaction, we say primary alkyl halides are stable, and then secondary alkyl halides, and then we have tertiary alkyl halides. So for primary alcohols, you should know that they will undergo SN2 reaction. Let us look at another example. Suppose you have this reacting with but let us take our example. So what happens here, the first thing that will happen, we're going to, this is a very strong leaving group, so we are going to protonate. After protonating, we are going to have water as our leaving group, and then we have Br, so in this case you can see that once our leaving group leaves, we are going to have a tertiary carbocation which is stable. So we don't have to, actually let me say, the nucleophile doesn't have to attack the moment the leaving group leaves, because if the leaving group leaves, we do have a stable carbocation ion. So in this case, rate limiting step is possible. So we can say plus the group that left the substrate. We're actually looking at this step now. After the living group has left the substrate, we have this. Then from here, our BR can attack the carbocation ion. By the way, the reaction will be very fast. And then we have BR plus this water here that we have. So you can see that this is an alkyl halide, and then we have water. Now the moment we have a rate limiting step, this will probably be SN1. In the next lesson video, we'll be looking at more examples. That's it for this lesson video. This is Wahula SJ. Thank you very much.